Alright, this is Algebra 2, Week 2 assignment of solving equations. This video will take care of the first 8 or 9 questions. Question number 1 says the roots of the equation are, and 2 of the answers have nice numbers and 2 of the answers have complex numbers. That means a real number part and an imaginary number part, which means there is a good chance that this equation would need a quadratic formula. So I'm just going to go ahead and jump to that instead of trying to factor. X equals negative b. Of course it's a quadratic because it has a square, so that means I could try to factor. I could do quadratic formula, which works for all of them, or I could do completing the square, which works for all of them. Quadratic's usually my method of choice if I don't think I can factor. Alright, so my a is 1, my b is 2, and my c is 5. So negative 2 plus or minus 2 squared minus 4 times 1 times 5 all over 2 times 1. Clean up the radical. 2 squared is 4. 4 minus 20 is negative 16 over 2. Square root of negative 16 is 4i all over 2. And of course, if you have a complex number, you have to separate the two pieces. So negative 2 over 2 plus or minus 4i over 2 simplifies to negative 1 plus or minus 2i. So negative 1 plus or minus 2i would be choice number 3. Number 2 is asking us to solve an equation that has radicals in it. And usually we tell you to isolate the radical and then square both sides, and quite frankly we can't do that because even if we move the other radical to the right, we get square root of 2x plus 5 plus 1. And if we square both sides, that would require that we double distribute the right hand side, and that's going to make all kinds of mess. So when you get a problem that's just going to be really long and really messy, and it's only worth 2 points for multiple choice, backdoor approach is actually the more efficient and logical way to do this. And the backdoor approach says if they give you an equation and they give you possible answers, in math, the way you check your answers is to just plug them in and see if they work. And I have to believe that's the intention of this problem. So we're going to plug in answers and see what works. So I think the first thing I'm going to do is plug in the 2, because I notice that there's 2 in 2 different answers. So if it doesn't work, I eliminate 2 choices right off the bat. So we're going to fill in the 2. 2 plus 14 under that radical. 2 times 2 plus 5 is supposed to equal 1. My first radical gives me 16. Square root of 16 is 4. This radical gives me a 9. Square root of 9 is 3. And 4 minus 3 does in fact make 1. So 2 is a good answer. So I know it's either got to be choice 2 or choice 4. So now I'm going to plug in the 22 and see if that one works. 22 plus 14 minus square root of 2 times 22 plus 5 is supposed to equal 1. So 22 plus 14 is 36. Square root of 36 is 6. This is 44 plus 5 is 49. And square root of 49 is 7. Is 6 minus 7 equal to 1? No, it's equal to a negative 1. Therefore, 2 is our only answer choice. Now that backdoor that I just showed you can honestly work for pretty much any time when they give you an equation and they give you possible answers. You could plug them in and check. Now when you get complex numbers, those aren't the easiest things in the world to check. Doing the straight math is probably better. Question number 3, that backdoor that we just took for number 2 would work out fine. However, this is one where the math is actually pretty straightforward, so of course I'm going to show you that. So you have that square root isolated. We are going to square both sides of the equation. So that gives me x squared. A square and a square root cancel out, equals 3x plus 40. I now have a simple quadratic. I'm going to set it equal to 0. And I'm looking at all my answer choices. They're nice pretty numbers, which means I should be able to factor this thing. Two numbers that multiply to negative 40 and add to a negative 3 would be negative 8 and positive 5. Set each one equal to 0. You get 8, or you get negative 5. Now, last week's assignment with rationals, we said that if you ever had a fraction in the equation, you had to check your answers to make sure that it didn't cause an undefined fraction. Well, when you have square roots in the equation, you need to check your answers to make sure that they actually do work. Radicals are kind of tricky sometimes because you can get positive and negative answers. So I'm going to check them over here. So x is 8, and I want to see if that works out to 3 times 8 plus 40. So is 8 equal to the square root of 64? Yes, it is. So 8 is a good answer. I'm going to have to check the negative 5 on the other side. Negative 5 should be equal to the square root of 3 times negative 5 plus 40. So negative 15 plus 40 is 25. Is the square root of 25 negative 5? No, it's not. It's positive 5. Now here's the clarification. Whenever you solve an equation that doesn't already have a square root, you get the positive and negative answer. If the equation already has the square root in it, if they want to use both the positive and negative, they would have to indicate that with the positive negative sign in front. If that positive negative sign is not there, then they're only referring to the positive answer. Therefore, the square root of 25, since the radical was only there, they are only talking about the positive 5, not negative 5, so 8 is our only answer that works. Alright, number 4. If the solution of that equation is expressed in a plus bi form, what's the value of b? Well, first of all, if it's expressed in a plus bi form and they only want the b, that means they don't want the I. So number 1 and number 3 are out because the I is not a part of the b. It's next to the b. So we do need to do some solving to figure out which one of the two it's going to be. So I'm going to go ahead and distribute this. That gives me 4x minus 2 equals 5x squared. And I'm going to set it equal to 0 and do quadratic. And I know I'm doing quadratic formula because if I got i's in the answer, factoring is not going to be easy or recommended. Alright, so x equals negative b. So since b is negative 4, that turns it to a positive 4. Plus or minus b squared is 16. Minus 4 times 5 times 2 all over 2 times the a, which is 5. So x equals negative 4 plus or minus square root of 16 minus 40 is negative 24. Of course, you can just type that in your calculator if you need to. All over 10. 24 has to be simplified. 2 and 12, 2 and 6, 2 and 3, group of 2. So x is equal to negative 4 plus or minus a 2 comes out with an I because of the negative. 6 stays in, all over 10. And if you separate the answers, you get negative 4/10 plus or minus 2/10 I root 6. Well, that's still not one of the answer choices, but the 2/10 simplifies to 1/5. Remember, we said we don't want the I in the answer, so it's the root 6 over 5. Alright, here's another radical equation. They give you possible answer choices. It's multiple choice. If you really wanted to, you could take each answer, plug it in, and see if it works. But I'm going to show you the math way. You got to get the square root by itself, so I'm going to add 1 to both sides. Since the radical is isolated, I'm now going to square both sides. Remember, I have to wrap up the entire side in parentheses and square it. Squares and square roots cancel out. So now that parentheses is being squared, that means I have 2 of them being multiplied together, and I need to double distribute. So I I get x plus 1 equals x squared plus 2x plus 1, which is a quadratic, so I'm going to set it equal to 0. And when I set it equal to 0, I get x squared plus x, and that's it. Well, all my answer choices are nice. That means I can factor this. First form of factoring is GCF. I can pull out an x. And when I do, I get x plus 1. Set each factor equal to 0. And we get 0 or negative 1. However, since we have a radical in the problem, we have to check both answers to see if they work. So that's kind of why doing all the work is sort of pointless, because all we're doing is checking the answers anyway. So when you're taking your Regents exam, feel free to just check the answers. It's multiple choice. I think they pretty much expect you to do it that way. Alright, so anyway, this is good for the show all your work part, so that you know what you're doing. Fill in the 0. 0 plus 1 is 1. Square root of 1 is 1. 1 minus 1 is in fact 0. So 0 is a good answer. If I plug in a negative 1, negative 1 plus 1 is 0. Square root of 0 is 0. Is 0 minus 1 equal to a negative 1? Yes, it is. So both answers are good. We're going to choose choice number 3. Alright, number 6 kind of has a fraction involved, so it kind of looks like the problems that we did in the last week, doesn't it? Well, I see subtraction. I hate subtraction, so should you. But I'm looking at those nasty answers and going, you know what, there's quadratic formula involved in here somewhere. It's in that form. Okay, so, yeah, we need common denominator. So I'm going to put the 5 over 1, and I'm going to put the x plus 3 over 1. My common denominator then is just the x minus 1. I'm going to multiply top and bottom by x minus 1. We need to double distribute on that first one. So x squared plus 3x minus 1x minus 3 all over the common denominator. Negative 4 stays the same. Distribute your 5. Denominators are the same, cross them off. Combine like terms, we get x squared plus 2x minus 8 equal to 5x minus 5. Like we said, with those answers, that's definitely quadratic formula. So let's set it equal to 0. X squared minus 3x minus 3 equals 0, and x equals negative b, so that's going to turn to a positive 3. B squared is 9 minus 4 times 1 times negative 3 all over 2 times 1. So we get 3 plus or minus square root of, let's see, 9 plus 12 is 21 all over 2. Since that 21's, is that 21? Yeah? Did I do something? Alright. I think I messed something up here. I know I don't get eyes, but what did I mess up? Oh, that's a negative 7. Sorry, that's a negative 2. My C is negative 2. So if you already caught that, good job. Alright, so now I get 9 plus 8, which is 17. That looks better. That matches our answers. But again, no I. So it's got to be number 1. Number 7. Formula for work problems involving 2 people is shown below. T1 is the time for the first person to do the job, T2 for the second person to do the job, and TB is the time for both of them working together. Fred and Barney are carpenters who build the same model desk. It takes Fred 8 hours, so Fred is 8, to build the desk, while it only takes Barney 6. Write an equation that can be used the time it would take both carpenters to working together to build the desk. Alright, and then determine to the nearest tenth of hour how long it would take. Alright, well, we'll call the first worker Fred, so his fraction is 1 over 8, and then Barney would be 1 over 6, and we're looking for how long it would take them together. So there's our equation. Now we have to solve it. Common denominator. Lowest one's 24, but most of you guys will probably think 48, because 6 times 8 is 48 with an x. So we'll make them all match. Multiply the first one by 6x, the second one by 8x, and the last one by 48. So we get 6x over 48 plus 8x, 48x, over 48x plus 48 equals 48 over 48x. Alright, drop denominators. We get 14x equals 48, 5 by 14. Alright, so I have a feeling that the reading of this problem much longer than the actual doing of this problem, and when I divide I end up with 3.4. Alright, number 8. What is the solution when that equation is solved for x if w is a positive integer? Well, it's looking like to me w is a positive integer. We got two options here. We could do quadratic formula, or I think we can just factor it. We'd be factoring out a w. That'd leave us with x squared plus 1 equals 0. Now it says w is a positive integer. X squared plus 1 can't be factored anymore because it's not difference of squares, it's adding. So I'm ready to set them equal to 0. Well, if w is an integer somewhere, a positive number, can a number ever equal 0? No, that's called an extraneous root, so we cross that one off. We're actually solving for x, that's our variable here. So I can subtract 1 from both sides, and then to get rid of the square, I square root both sides. And anytime I put a square root into an equation when I solve that wasn't there to begin with, I get a positive and negative answer, and the square root of -1 is the definition of an imaginary number. So I get positive and negative I. If you had wanted to do quadratic formula on this one, your A would be W. You don't have a B term because you don't have the X term, so your B would be 0, and your C would be W. And you could go fill that in the quadratic formula, but even though that spells wow, I'm thinking, wow, that's probably going to be a little tough. So I kind of like the factoring way myself. But again, they gave you an equation for a question. They gave you possible answers. All you've got to do is fill in the answers and see if they work. Problem is that W. So if they say W is a positive integer, make one up. Okay, so you could put like a 5 in here. Stay away from anything under 2. And then when you make that up, you could plug in the -1, see if it works. And you can plug in i's and see if it works. But still, the math way, factoring, I like that the best. Number 9. A number minus 20 times its reciprocal equals 8. What's the number? Alright, so you have a number minus 20 times its reciprocal. So the it's referring to is the number. A reciprocal is when you flip the fraction, so that becomes 1 over x equals 8. So if I multiply these two together, I end up with x minus 20 over x equals 8. Common denominator is x. Multiply the first fraction by x over x, the last fraction by x over x. I get x squared over x minus 20 over x equals 8x over x. Cancel out the denominators. X squared minus 20 equals 8x. Set it equal to 0. X squared minus 8x minus 20 is 0, and I'm noticing all the answers are nice, so that means I can factor. -10 times 2 will give me what I need. Set them each equal to 0. X equals 10 and x equals -2. Now remember, when you have a fraction in your equation, you got to make sure that neither one of those answers will cause an undefined fraction. So if I put a 10 in there for the x, I'm good. If I put a -2 in, I'm good. So 10 or negative 2 are my answers. Alright, so here's the solution for the first 9. The next 8 will be in a separate video.